Hi, welcome today. We're going to be talking today about a synergy between three OpenStack projects, being the Senlin project, which is a new project, which is being nominated for Big Tent. And Julio, my partner here, is a contributor to that project. The heat-translator project, which you know is a part of the Heat project, which takes the Tosca Standard description of applications as templates and is able to orchestrate them, and the Magnum container service. We're going to show how these three projects are working together and have started working together in the Liberty release and what our plans are in the Mitaka release to enable it to do policy-based scaling, update, and a lot of things automatically using the Tosca description language. So.
Thanks, Matt. So important thing to point out here is the Senlin architecture follows a similar architecture as many OpenStack core services. You've got a Senlin client that processes requests via REST to a Senlin API. The Senlin API handles those requests and sends them over RPC to the Senlin engine. And it's important to point out that the RPC, that the message handling there conforms to the typical message handling that you have within OpenStack. So there's reuse of Oslo messaging to support that RPC mapping. The important thing to point out within the engine is there are two specific constructs that are critical to Senlin to provide the support that it provides. One is profiles. And profiles provide kind of an abstraction for describing the services or the resource interfaces within a cluster arrangement. Policies provide the rules that are associated that you can process within the various different actions that happen within the cluster. And then finally, the Senlin database provides persistent store for the policies and profiles that are associated with the cluster. This diagram represents the policy types that you see on the left-hand side describe the rules that you can use in managing the cluster resources. In particular, placement. So placement, you can think of it as rules for placing specific resources within a data center or an availability zone, et cetera. Policies work with profiles, and profiles kind of describe the resources that you're looking at with respect to the various different services that OpenStack provides. So you can have a group of resources that are specific to heat stacks or Nova service or ironic bare metal, et cetera. And on the right-hand side are your clusters of objects within the Senlin service. So Senlin can provide a cluster of containers, stacks, VMs, bare metal, etc. So the important thing here is that you can manage the cluster resources in a singular way. So you can have placement policies or health policies, scaling policies associated with a cluster of resources around either containers, stacks, VMs, bare metal, etc. Okay, and then for the Mitaka release, we're proposing an integration of Senlin and Tosca. So a few of the bullet points that we're looking at is a roadmap for blueprints related to working natively with Senlin with the policy format, accepting the Tosca format to express clusters and containers as Tosca templates, and then working with the heat-translator service to parse and validate and deploy the templates. And again, an important thing to point out here is that Senlin will map the Tosca policy constructs to triggers within the Senlin service and allow for the plug-in to various different cloud monitoring services. Like in this example, we have mapping triggers to Manaska, but we have examples for ceilometer right now, and you can envision examples for Surveil or for Kilo Eyes, any of the existing other numerous cloud monitoring service that you have within OpenStack. Important to point out here is that Tosca provides a standard container app definition, and the model that you see there is a Tosca model, and Tosca allows for various different capabilities that can be monitored, that can be described as requirements. So in this case, we've got a YAML file that describes, and this is an example for a Docker container, but you can envision the containers model within Tosca are kind of agnostic to the underlying container technology. So you can envision other container specifications here as well. But the example here is for Docker, and you can notice that the capability definitions here this is a realization of a normative Tosca type Tosca capabilities container, and you can express your specific Docker representation of that here, and we've got properties for the Docker instance, CPU frequency, disk size, etc. One of the important features to point out here is the attribute feature. So here's where we can specify a utilization attribute, and that utilization can be a value that can be monitored. So again, important point to point out here is that these can be expressed declarative, and they can be mapped to an underlying service to provide management and orchestration of these resources. You want to take over here?
Sure. So Tosca itself has finished its first version of the YAML specification. Heat-translator is an implementation of it. And we're showing here that Tosca has generic concepts like groups and container applications that can directly translate to something like Kubernetes. So what we're looking to do is create a demonstration in Mitaka, enable this demonstration, to be able to take a Tosca group descriptor and map it to a pod, and take a Docker descriptor and map it to a container that can be wrapped in this logical group or pod, and attach policies to it. We can attach different scaling policies, for example, here. We can attach one to the pod, we can attach another one to one or more of the containers. And Senlin will be able to consume those Tosca constructs using the heat translator's parser and be able to manage them regardless of the type of profile the target containers. In this case, would be for a Magnum service. We work with Magnum to deploy this Kubernetes example. It could work for any type of cluster or any type of container.
Yeah, and just a plug here, we've got a presentation later on Thursday that talks about a demonstration that we put together for integration of highlighting how Magnum Senlin can work together to demonstrate two-level auto-scaling for both your containers and your cluster resources.
So to get into some details, so you can see on the left side the Tosca descriptor, which is a standard, and we can describe a generic logical group here, which has all information and color-coded, and the example of one of the containers in the pod or group in Tosca, and there's a relationship. There's a membership relationship from the node or resource to this logical group, and we can actually use the heat translator to add custom plugins to be able to translate Tosca to Kubernetes YAML, and that's how we show in the color coding where things in Tosca are described and where they would appear in a Kubernetes YAML. So things like the overall container descriptor would come from the group descriptor in Tosca. The underlying Docker containers would go underneath the group descriptor as independent container descriptors. In this example, we have Redis, a Redis master container, and we show how the network stuff, the port information, the CPU information, the storage information gets translated from Tosca to Kubernetes. And we just point out that this plugin model will enable other types of containers. So right now we work natively with heat hot language, heat containers, heat stacks, but we could actually add plugins for other types of containers. The important thing that Tosca brings to the table for Senlin is normative, standardized policy descriptors. Tosca has a very strong notion of what constitutes a policy. It's basically a application requirement that can be decoupled from the application or attached to different parts of the application resources. And we describe it in terms of event, condition, action. So a trigger talks about these three things, event, condition, action, as one thing. And I show here what constitutes event, condition, action in a Tosca descriptor. The event, we have a limited number of Tosca event types, which can map to, which can be described further through a filter to say what types of resources that event can come from. So we might have a utilization event, and we describe a resource like a compute node. So we know what this policy can be attached to and where to find it in the application topology. Then we can further describe the condition for that event. So when we register, we basically, Senlin will take this policy, look at the event type, know which type of event to register with Ceilometer or Monasca or Kilolines or whatever it might be, and what type of condition it's looking for. In this case, it might be utilization or something like that. Then what happens when that alarm gets triggered? The trigger then has an action component that is invoked, where a person can register per application basis a method to be called within Senlin and pass a number of parameters to that method that makes sense to this type of event that will be used to correct this. Typically, we pass in strategies. There'll be common strategies on how to correct things automatically, or you can get very detailed in how you want to correct the problem when it occurs. And you have more than one trigger, so an individual policy can have multiple triggers for multiple resources in your topology. But again, the standard format is what brings some sanity to Senlin. So I'm going to move more quickly to the thing. So to talk about the parts of a Tosca policy definition. The Tosca policy definitions are standardized. They basically focus on operational policies, things to do with the things Senlin wants to describe, the updates, the placement of things relative to containers, logical containers, your infrastructure, and scaling. So you'll see things supported in the language and the grammar of Tosca to support all the things we need to do in a single definition. Specifically, if you've ever looked at Senlin, you'll see that every one of the policies looks slightly different, and we're showing in the Mitaka release how we're going to normalize that with Tosca. So some things like versioning are already in Tosca. We can version policies, so you can actually manage policies independently of your applications and marry them together when it comes to deployment time. You can also recognize when a policy's been changed. If you're an enterprise that wants to update their scaling or their update policy, you'll know when those versions change. You also have a scheduling concept in Senlin, which is actually something that we're taking back into Tosca. So we're actually adding a schedule component to the policy definition, so you can actually say when this policy is valid for what dates and times and things. We have alarms. The alarm, instead of alarm concept, that maps to being described about the event. The event is actually a generic Tosca thing that maps to Ceilometer. Implementation here, you can see on the right, is a Ceilometer implementation. Then, of course, the handlers. The handler is the action. What hook do we call? What service or plugin do we call in Senlin? And what operation do we call? And what parameters or inputs do we pass to that function? And there were some things in Senlin in terms of credentials, and we basically have been talking about credentials should not be baked into your policy. You shouldn't bake anything security-sensitive things into your policy. So we're working on making sure those are separated out from Senlin policy descriptors. Placement policies, very important to note that we can describe multiple policies in the same realm. So you can have policies for placement that talk about availability zones, about regions, but more importantly, these things can be aggregated and combined with customer policies. So we have customers who might want to describe their own containers. They might have within a availability zone in a given regions, they might have their own thing about a compliance level. So maybe I have servers that are compliant to a certain security level. Those are containers that are outside of Tosca. So Senlin will let you put service plugins in to be able to work with the Senlin engine to basically supply your own policies on how things are placed.
I think we're going to wrap it up.
Yeah. The last thing to show is the load balancing. So load balancing is a policy. We're showing how it can be mapped to Tosca in the same way. But also I wanted to point out that we're the Tosca group concept you can actually attach your own load balancers as part of the topology. So you can either describe load balancing as a policy and let someone take care of it, or you can actually describe your own load balancers as well as part of your container cluster descriptor. And as Julio mentioned before, their talk is on Thursday. If you want to hear more about Senlin, which you should, it's Thursday at 9:50 a.m. And of course, we're looking for contributors to help us implement a lot of this function going forward in Mitaka, both the Senlin project and the heat-translator project, and they're the links to those. So thanks very much.
Thank you.